Hey guys, so I just got this crude setup here to test this circuit out. So I have these LEDs here, they're opposite to each other. You can see each side of this power supply is feeding one LED. Like this side here has these two SSRs, and this side has these two. So these two turn on this LED, and these two turn on this LED. You can see the polarities reversed right here. So if they both turn on at the same time, if like there's any short circuit, the power supply will short out and the LEDs won't turn on. So I can show that right here. See, this is the app. Is it connected? Yeah, it's connected. So one turned on there, right? So if I turn the other one on too, it shorts out and see the power supply turned off because it's shorted out. So now I'll turn on this one. So in a couple minutes here, it's going to do a cycle. You can see, go to this page here, and here's just a quick setup I put on here. It'll turn on for 1 minute, and then it'll turn off for a minute, and then the other one will turn on for a minute, and then it'll turn off. You could just put as many schedules as you want, I think. I didn't find a limit for the schedules with this app anyway. So you can see here in about 2 minutes or less, probably it's over a minute now, it will turn on. It'll do a cycle, and you can see here's the current, right? I'll just turn it on here quickly. See, it pulls about 20 extra milliamps when I turned it on. But when you use just this is the same circuit. When you use these here, it pulls an extra 50 milliamps. It pulls over 100 when you turn just one of them on. And with all four of them on, it pulls 300 milliamps. This is with 8 volts going in. These are 5 volt. And I'll show you something too at the end of this video that you have to watch out for with this circuit if you're going to build it. And I'll show you how to avoid it happening. But if you'd be better off just to use these if you don't care about the power draw. See, there it just turned on. It's doing it itself. And you can see on the app what it looks like too. But that's not me doing it. So I'll just leave it do its thing here. And also, this is another setup you can use with an Arduino. You can program it to do the cycles like that with the Arduino, which might be better than this setup. This is something I want to build for just to have it on. You can run a motor and leave it run by itself. There's some other things too I want to cover coming up in some other videos here too, with some I've never ever talked about, but it's really important to having a self-runner, especially if you're using big batteries like I've never showed it on my channel before, but what you want to do is always have your batteries. So let's just say you're running 48 volts on your output and you're running 12 on the input. Well, those 4 batteries on the output that are in series should be switched to paralleled on the input, and then your input batteries put into series on your output when your battery circuit switches. And there's a reason for that, and it's called Parrelled exponent. If you haven't heard about it, it's pretty important when you're using batteries. See, it had turned off for a minute, and now this side turned on. But it's in some charge controllers and smart shunts that have that built right into them. You choose what type of battery you have because every battery chemistry has a different Perkert exponent, like it's called Perkert, and it applies to discharging batteries and amp hour capacity. It doesn't apply to charging. It's really important when you're looking at this stuff. It comes into effect, and I'll have some videos here documenting it, showing it. I'll do some graphs with, like, showing you the results. With new chemistry, I have a few with lead acid, but I'll do it with the new chemistry. So there, it just did its thing here. But I don't think I had the circuit, the timing done right here on this one because there's still one that's on here. I didn't test it. That's another good thing to see with that, is because if you do have anything wrong, just make sure you have a fuse in the system or run a light bulb or something that's not going to short out two batteries. So yeah, you could see it never turned off properly. That's just because I programmed it wrong. It's 23. It's supposed to be 22 right here. Like in an hour it would have turned off. But that was just me not double checking. That's why that happened. And you can also turn these on and off manually. Which one is that? Here's all. So I want to show you something else too with this if you're going to use it, and I'll show you how to avoid it. Is when you first turn it on, connects. See, I just took the power off to it right here. Now watch what happens when I connect it. See, it tries to short itself out. They all turn on for a split second. Well, 3 of them turn on. And you can see the SSRs turning on. The lights don't turn on because it shorts the power supply out. If that was batteries, there'd be a lot of sparks and arcing right now, melting wires. So keep that in mind. And let me just show you this one, the current draw, the difference. I won't hook it up to a SSR because I'm just going to turn the relays on. I'll show you how much power the relays take, which some people might be alright with, and it'd be way easier to build the circuit by just using the relays. So you can see the power draw, it's the same as what we were before. Now I'm going to turn a relay on. I'll manually turn it on if I can get my hand in there. See it pulling over 100 milliamps. I'll turn another one on. Now we're almost at 200. 3 of them on, pulling almost 250. And here's 4 of them on, just about 310 milliamps. So you're looking at, I don't know, 2.8 watts or so, I think, just off the top of my head, somewhere around there. Which still isn't bad though. You have these normally open, normally close, right? But the circuit is going to take 8 of these for a basic circuit, because you're switching high side and low side. But just keep that in mind. And if you still want to use SSRs without having them short out when you turn it on, you see how these ones don't turn on? That's because there's a resistance on the coils, and these coils measure 69 ohms right here and here. That's the coil circuit. So if you want, this is positive, this is negative on the circuit. on each one. So what you want to do is put a 70 ohm resistor right here, and that'll stop your SSRs from turning on when you first power it up. Because what you can do with this type of a circuit also is have one dedicated relay that turns on this when it's time, because the schedule is always going to stay. You don't, even though you power it off, your schedule's still there, and it hooks to Wi-Fi instantly. Like you could see here, it's already hooked to it. It doesn't take long at all. So you can have the resistors in there, and if you want to use SSRs, and like I said, you can have one of these, just one of these switches out of one of these four here on another one of these, turning your battery circuits on. Like, you know, they don't have to be always on. If you're gonna switch every hour, you could have it turn on a minute before these ones are gonna turn on. Give it a little time to connect to the Wi-Fi, and you'll be good. Other than that, though, I'm gonna pull out my Arduino and see what type of programming I could put on one of these. Program it to see, you know, how much better that one is compared to these. This one's kind of simpler, you know, you don't have to put a bunch of code. It's just an app. If you get it right, it'll work. But just wanted to show that. Oh yeah, another thing too I want to show is to pull these out. Isn't easy. You're gonna need a good BGA hot air system here. A good one, because, well, you can make do with a cheap one, but you know, if you're gonna be into this stuff, I recommend getting a good one. And what you want to do is get some good flux and use leaded solder. This is 60% lead. Then put leaded solder on your connections. These ones right here. Just add extra leaded solder on them, because you'll have a hell of a time trying to get it off without the leaded solder. And then clamp it to the table or whatever. If you have a special vise or something you want to put it in, be the best thing. And then use your hot air to pull it out. Grab your relay like that. Just get it really hot, and they'll eventually come out. It takes a bit though. Anyway, hope that works. Anyway, this is just for like either one input and one output, or two inputs or two outputs. You're gonna need 4 of these, so you would need 2 of these minimum to have both high side and low side. And then if you want to have your series parallel, I'll show you kind of what I drew up quickly here. I still have it. Yeah, so your series parallel is going to kind of look like this. You have your 2 batteries, right? And then you'll have 3 switches, and that's just for basic doubling your voltage on the output. So if this was the input, you'd close this switch and this one, so that parallels it, and then your output would be close this one, and then there's your positive and negative, and these 2 are open. So you're going to need another 6 SSRs to do that, which isn't too bad. If you want to have 3 batteries on the output, you'll need 9, you know. Every time you'll need 3. But anyway, just a quick rundown of the circuit. and how it works and a few other things that go along with it. Thanks for watching, guys.